Welcome back, class. It is Tech School Grade 3 Science Week 12. Let's get started right away with going over our homework. We have a busy class. Our quizzes. Question number 1. What is the biggest? The biggest is the sun. The sun is the biggest. How does the Earth move? Does the Earth move around the moon? The Earth doesn't move at all, or the Earth moves around the sun? Yes, the Earth moves around the sun. Good job. Next, we have number 3. Why does Earth have gravity? The sun is hot. Well, yes, the sun is hot, but that's not the answer. The Earth is really big? No. The Earth is really big, but is that a reason for gravity? No. How about the Earth spins really fast? Yes. Because the Earth is spinning so much, everyone is stuck on the ground. Now, why does the Earth spin? Cars driving? Because there's so many cars driving, it makes the Earth spin? No. Lava and volcanoes? So lavas and volcanoes make the Earth spin? No. The moon. The moon helps the Earth spin. Remember what we talked about? If the moon is closer, the Earth will spin faster. If the moon is further, the Earth will spin slower. And that answers our next question. If the moon is closer, Earth will spin faster. Things fall and stay on the ground because of gravity. Every 1 second a ball is falling, it will be the same speed? No. We can see this is getting faster. What force makes a car move forward? Air resistance or drag? No, that makes it slower. Friction? Slower. Gravity? Slower. It is the engine. What stops the car tires from spinning? Gravity, road, or brakes? It is the brakes. The car brakes make the car stop moving. And finally, number 10. This is an example. You don't actually see a triangle, a square, and a circle. Well, there is a circle. But which one do you think has the least wind force? Is it going to be a square, a circle, or a triangle? Yes, a circle would have the least wind force or air resistance or drag, less than a square or a triangle. That another way to say a circle is more aerodynamic. Like a sports car. Okay? Now, for our lesson, let's begin with our forces. But let's review really quick. What forces did we learn already? We learned about push, pull, friction, gravity, wind force, air resistance, or drag, and engine, which is called propulsion. Now, today we are learning something interesting. We finally found the word Newton. And it's not like Newton, your classmate. It is like Newton, force. Forces have newtons. But what does that mean? Well, if you have a number of newtons, you can make something move faster, slower, change directions, or stop moving, because the force is pushing on the objects or pulling. So let's take a quick look. This is an example of newtons, and this is the force. The engine has a 500 Newton force going forward. The air or the wind has a 100 Newton force going backwards. So it's stopping the car. The tires have a 200 Newton friction force stopping the car. And gravity has a 50 Newton gravity force stopping the car. So I asked a question. Can the car move? Let's find out. What is 500 minus 200 stopping equals, well, let's add up the backwards forces first. So let's have 100 plus 200 equals 300. 300 plus 50 equals 350. So 500 minus 350 equals 150 newtons going forward. That means the car can drive forward. The engine is strong enough. Okay? That is how newtons work. We have many forces, and the amount of newtons tells us which way we will move. If these forces are bigger, maybe the car will go backwards instead of going forward. So the two main forces we learned were pull and push. Let's look at a couple examples of pulling and push forces. But for this, I am going to need my assistant. So this is Mr. Bunny. Bunny is going to help us learn pull and push forces. So Bunny is trying to run away. So this will be a pull force. See? I am pulling the bunny. Ooh, Bunny ran away using his push force. All right. Well, today's assistant didn't last too long. He used his push force to run away. He pushed his feet against the ground and he ran. So that is an example of push and pull forces. Now let's take another look at what we already learned. We learned about the pull force of the Earth on the moon. See, the Earth is always pulling the moon, and that's called the gravitational pull. And we also have the push force of a car. The propulsion force, or the engine, is actually a push force, because the engine is pushing these pistons. These pipes or things inside of the engine are being pushed up and down, up and down, up and down. And this energy it makes is going to the tires to make them spin. So the engine is actually a big push force. It is causing a reaction to spin the tires. Now, let's go to the next page here. We have contact and non-contact forces. While we have two categories, let's move on a little bit quicker here because contact means touching. So there is force with touching and not touching. Okay? So non-contact, there is no touching going on. But contact, there is touching. For example, if I touch the bunny, I am using contact force. So let's answer this question. This boy is using contact force to pull the bag. And the non-contact force is this magnet. Nothing is touching, but the iron is moving. So let's take a quick look at the types of forces. Contact forces, we have applied force, like physical force, where we have to move something. There's springs, there's drag, wind, or air resistance. Yes, that is a contact force. You are being touched by the wind. The wind is touching. The air is touching the parachute. Okay? The air is touching you when you are running, and it's making you slow down. And friction force, you are touching the surface. And of course, normal force. Non-contact forces, magnets, electricity, and gravitational force, or gravity. Things falling is a non-contact force. There's always gravity on everything. Okay? So let's take a look at what this is like with magnets. All right, we'll skip over here to page 85, and we are going to start magnetic forces. Let's go over the types: magnetic force, electric force, and gravity. Okay, those are the three non-contact forces. Now, for magnets, we have attractive or pull force, and we have repulsive or push force. Okay, so pull and push. These two words, attractive and repulsive, are pretty important. Attractive we use very often in English language. If something is attractive to us, for example, candy and chocolate and donuts and cake are very attractive to us. But something like broccoli and vegetables and coffee can be repulsive. That means we want it far away. We want coffee and vegetables far away from us. But candy and cake, we want to pull closer because it is attractive. So how do we use magnets exactly? Well, if you see here, this says S and N. These are the north and the south poles. They're opposites. And let's take a look how that works. Opposite poles attract north and south, or positive and negative. So if you see north and south, these forces will attract each other and always try to connect. Same with south. So these magnets will come together very fast. But the same poles repulse each other. So repulse means push away. It means you can try to push them together, but they will always spread apart. So you can see this one is moving backwards and this one is moving away. This is the repulsive force because it does not like the same pole. Now, electrostatic forces are the same thing. They're with the positive and negative. And actually, magnets are metals that are charged by electricity to become charged. So a magnet is a charged metal, like iron. But not every metal can become a magnet. Well, let's watch a quick video about magnets. There you have it. That's the repulsive magnetic force. And here is the attractive magnetic force. See, the opposite poles attract each other. Let's see what happens. Alright, good job. So that is our video. Let's get back to our class. That's a demonstration of some magnets you can see. You can look at more videos after class. Electricity is the same thing. These ions or electric forces are actually inside of the magnets. And those positive and negative forces go into the opposite side of the magnets. So all of the pluses will go on this side, and all of the minuses will go on the other side. Okay. So let's take a quick look at electric forces in everyday life. There is lightning and static electricity. So static can make your hair stand up, and you can even shock your friends like bzzz. Okay? So that's electricity. You can also find electricity in everything. When we're charging our phone or we are cooking, we use electricity for everything. And what about gravitational force? Gravity. Well, gravity is what happens when the Earth is pulling on the moon, or when leaves are falling to the ground. This is all about gravitational force or gravity. Okay, so our quizzes this week is going to be about forces again. I hope you really think forces is cool, or forces are cool, and we will continue next week. Good job, guys. See you later. Bye-bye.